Hello everyone and welcome to my channel. Today we are going to discuss on the operation of Atomic Absorption Spectrophotometer by PG Instruments Limited, United Kingdom. As you can see, this is the PG AA500 Atomic Absorption Spectrophotometer. Now, before we start, I would like to formally talk about each and every components of the atomic absorption spectrophotometer. But before we start this part, it will be very good for you to understand today's discussion. Those that have not listened to previous video on principles of atomic absorption spectrophotometer, it will be good to go back and watch that before coming to this one. So in order to start, this is the machine, Atomic Absorption Spectrophotometer AA500. As you can see it here, boldly written. Now, for this machine to work, there are a lot of components that work alongside it. From our previous discussion, we talked that hollow cathode lamps are specific to each element, and this is the hollow cathode lamp for potassium. So this is how the lamp looks like. This is what supplies the light of a particular wavelength, particularly or clearly about that particular element. So with this lamp, only the light of the wavelength that can be absorbed by potassium can be supplied by it. Now and again, AAS works with air acetylene. This is the acetylene gas cylinder. I'm trying to turn it on now so that and make sure that the pressure is set at the appropriate gauge. You can see the acetylene gas, I've taken a record of it. So this is the air compressor. This is what supplies the air, and the air gets mixed up with the acetylene and then powers the machine. Then this is the fume exhaust chamber. If this is not working well, then whoever that is operating the machine may be exposed to fumes from the individual metal. Then as well, inside this component is where this particular place I'm touching is the nebulizer. It is the nebulizer that enhances the automatic suction of the sample to the burner. This is the burner. This is the burner head. So if the nebulizer is working well, it will pneumatically suck samples and introduce them to the flame as aerosols. Then in this particular component of the machine is where the lamp resides. So this part you are seeing, this PG AA500 is 8 motorized turrets, meaning that it can hold 8 lamps at the same time. And this is where the detector resides. And this is the computer interface that you use to operate the machine. Now, since the sample, which is liquid, is pneumatically sucked by the nebulizer into the flame, there will be waste. The waste drain comes through this pipe and gets dropped in this bucket as waste, which will be thrown away as time goes on. So before we will start, I have to first of all turn the machine on. I have to ensure that so now I can turn the machine on. As you can see, the machine is on. So I now go to the interface where so the AA Windows is coming up now. So as you can see, the AA Win is on. So the next thing I need to do is to click on the Windows, the software here. This is AA Win 3.0. So I click on it, I double click, and then it comes to this place and I click OK. So now, as the AA wing is trying to initialize all the items that you can see here, which is the deuterium lamp motor, the element lamp motor, the atomizer motor, the burner head motor, the silt, and the wavelength motor. Once you finish initializing this stage, and then says, okay, we can proceed with other parts of the today's video. You can see the initialization process has finished. So you've seen that the interface is now bringing out select work lamp and the warm-up lamp. So suppose that I will select to pick the work lamp to the copper and then leave a lead as the warm-up lamp. The lamp is supposed to be allowed to warm up for 15 minutes before we start up any analysis, and it is supposed that we leave the machine to preheat for about 30 minutes. So since I selected the work lamp and the warm-up lamp, I have to click the next, which is to do the process. So we click next, click next. Now I'm adjusting the element parameter to fix it to copper. And if that is done, then the next thing we'll do is to search wavelength for copper. So we now search a wavelength peak for copper. So as you can see, it's trying to select the peak. So after the scan, the best wavelength selected is 325.05 nanometers. So we click close and then impute 325.05. Then we click next and finish. So as it has finished, the next thing we do is to set the standard into the equipment. So we click on configuration, go to sample wizard, then adjust to copper, and then click next. Then we set the standards that we've chosen, which is 0.625, 1.250, and 2.500. Then we click next, next, and finish. So as this has happened, is to ignite the machine. So you can see here that the support air pressure valve is on, and then the acetylene pressure status is on. So the next thing I do is to click on fire. So as I click on fire, as you see here, you see how the machine tries to ignite. They need to on the air compressor. Please, pardon me, the air compressor makes noise, so you may hear a slight noise. So we try to ignite the flame. So as you can see, the flame is on now. So we can start up our Yes, sir. So the first thing we'll do now is to adjust the energy. Then we zero the equipment before we can read the. So we brought the machine to zero. So we now impute the standard, allow the machine to take the observances of the standards. And as we kick it, we leave for some time so that we'll get the best. We've just taken the observance of 0.625. So the next we take the observance of, we allow the machine to measure the observance of 1.250. Then we allow some time to equilibrate so that then the last of the standards we are taking is 2.500. So as we can see, the relative factor here is 0.996, which is very okay. So we accept this because the calibration, as you are seeing, the calibration curve is good and the regression is so strong, 0.996. So we click OK. And then the next thing that we do is to analyze the sample. So as we fix that, we click on measure and then give it some time. And then we click on start. So as you can see, the sample that we run is not detected. Being not detected doesn't mean that there may not be trace amount, but it is below the detection limit of the machine. So now, as we are through with this, the next thing that we've seen that is important that is to be done is to save the data. So since this is a copper test, we have to save with copper tests. You see the last number that we have here. Okay, we have copper test 81. So we can save with copper test 82. So as we've saved the file, the next thing that we're supposed to do now is to turn off the gas, and then off the air compressor. Once we off the air compressor, then we come back to the system. Since it is run by an AA Win software, then we click close, and then it says OK. And then carefully, we come to start and then shut down the computer system. Once the computer system is shut down completely, then we turn off the equipment. Then we have to make sure that as we are done with the test, we have to off everything and off the fume exhaust. So as we are through with today's analysis, if you've enjoyed our video today, try as much as possible to like, comment, subscribe, and share these videos to your colleagues. Thank you for watching today. In our next video, we'll discuss about how to prepare standards and how to calibrate the atomic absorption spectrophotometer. Thank you for watching.